Okay, today we are going to look at our three log properties. It's a little bit different than the properties we've worked with before, which are solving one-to-one and changing base. Today we're going to learn about the product property, the quotient, and the power property. We're going to use these properties to expand and condense a log. So let's look at the property first that I have written for this addition property. It says the log of any base, we're going to call it A. If the input of that log has multiple things multiplying, you can split that multiplication of the input into two logs with the same base and add those two logs and split up those input multiplication values. So let's look at a couple of examples. The first one is log of x times y. So notice I have a product of two pieces. It can be variables, it can be numbers, and this is a base 10. Those are the easiest to write down because I don't have to write the base every time. And I can just split those up into addition. Make sure they have the same base, make sure that the sign is addition. So multiplication and addition go together. We can also do what we call condense. So notice I have three separate logs here. They're all the same base 10. And notice I have three different inputs. It wouldn't matter if they were the same, but I have three different X, Y, and Z. And notice that the sign in between them is adding. So they're adding means I can condense this through multiplication. So I can write one log instead of three, and I can say X times Y times Z. So these properties go both ways. First one would be called expanding. And this one would be called condensing. And you can write this on the flap, like when you open up the product property, the one that's on glued in, not underneath the property. Okay, next one is the quotient property. So quotient means division. So notice this one says if I have a log of any base and I have two parts that are dividing, I can split it up through subtraction. They're going to have the same base. So we're going to do that over here and show an example. Notice I have a log of base 10 and I have my two pieces here. This was not supposed to be a B there. I don't know what was going on. So that was a 5. There we go. And so what I can do is I can take my one log, base 10, and it's always the first divided by the second. So the left divided by right. And then if you can reduce that, you can go ahead and write this is log base 10 of 2. And that's what we will be doing is condensing on that one. And number 2 would be expanding. So notice I can take my log base 10, can take the top, that would be the numerator, write it first, then my subtraction sign, and then the denominator. Now notice on this one, if I wanted to keep going further, the first log also has multiplication. And so I could keep going, write this as addition, put some order of operations, and I could have split that up using both properties. And that's what we're going to be focusing on today is using all of these properties in one problem. Okay, the next one is the power property, probably the most important one when it comes to solving, which says if I have a log of some base and the input is an exponential, doesn't matter what the base of the exponential is. So it's not that property where the bases are the same of the log and the exponential. I can bring the power down in front of the log and multiply it to that log. Okay, so let's look at a couple of these. So here's my power. Oops, I'll pick the highlighter. Here's my power. It's 2. And what I can do is bring that power down in front of the log. multiplying. So if you can imagine, if that was a variable, this would be one way that I could bring down my variable from a power. And there we go. So that would be called expanding. Okay, and if I wanted to keep expanding this one out because I have multiplication, I could. I could say 2 natural log of x plus 2 natural log of y. Remember, because this power was on x and y, the 2 would have to be on both of these. In front, multiplying both log. Okay, next one. You might get confused on number 2. That's why I wrote 2 and 3 is. So this dividing of 3 is not dividing the input of 6. It is the multiplier in front of the log. So there's really a 1 out in front. So how we would really write this is 1/3 log 6. I would not divide the 6 by 3. That would be incorrect. Okay, and now I can raise it up as a power. And if I wanted to even take it somewhat further, I'd write that as a cubed root. And that would be called condensing. Okay, next one, same thing. So this would be 2/3 log of x, and that is equal to the log to the 2/3. And I'm just going to write this all the way out just so we remember how to go from rational exponents to radical form. So this would be the cubed root of x squared, because you're going to be using these properties quite a bit when you do your homework over the next 2 days. Okay, the last piece is I'm going to do a couple of examples like you're going to see on your homework where we're using all of these. You can write these problems on a blank piece of paper in your INB to the left or right, depending on where you glued these in. Or if there's some room below or somewhere you can write these, but they kind of take a little bit of room up. So what we're going to be doing is we're going to expand this log base 2. So we're going to take this input and we're going to split it up so I can write it as many logs as possible. That's the goal. And whenever I run into a power, I'm going to always bring my power down using my power property. I don't want to leave my powers up. I want to bring my powers down like I did in this problem on number 1. Okay, so that is called expanding. So the first thing I'm going to notice is there's 2 pieces multiplying. I've got this x to the 4th, and it's multiplying the radical. So I'm going to split that up through addition first. So I'm going to write log base 2 x to the 4th plus log base 2. Now when I write this next problem, instead of using a radical, I'm going to use my power of a rational power. So this is a square root, so this is raised to a half. So when you're expanding, you want to write all your radicals as rational exponents. Okay, so then I'm going to stop and then I'm going to look at what I have, and I'm going to start with my first log. Is there anything I can do with this first log to expand it any further? And I can't expand it through addition or subtraction, but I can bring the power down. So that's what I'm going to do here. And then that one's completely done. I have no more expanding left with that one. I just have a log base 2 of x. All powers are done. But if you notice my second log over here, I have a lot of things I can do. First thing I'm going to do is notice that I've got to bring that 1/2 down in front. And then that will break my parentheses off, and then I'll have division. So I'm going to take it one step at a time. And I'm going to say plus 1/2 log base 2 and then y over z cubed. Now notice that 1/2 of a power was going to the y and it was going to the z cubed. So as I split up further on this one, because I can still take this one further because I have division and I can use my subtraction property. So this log stays the same, it's done, it's already expanded as far. I'm going to take 1/2 log base 2 of the top minus, but that 1/2 was also impacting the denominator. So I'm going to bring that 1/2 also with a log of z cubed. Okay, now I notice that all three of my inputs don't have any multiplication or division associated with them. So they're just single monomial, no multiply. The last thing I'm going to do is make sure all of those inputs don't have any powers that need to be brought in front of the log. And the only one that I see is this last one, this z cubed. So it needs to come down and multiply to that 1/2. Okay, so this is what it will finally look. And then I would be completely done. And you might want to put parentheses around this saying order of operations, like I want to divide these and get this down to one binomial first, like if I was going to work it backwards. And then I would divide and then I would multiply my two pieces together. So I'm going to leave those parentheses as order of operations. Okay, so the next one is a condensing problem. And so what I want to do is bring this down to 1 log base 3. Okay, right now there's 3 terms. I want to bring them to 1. Well, the first thing I have to do is the exact opposite of what I just did. So anytime there's a number multiplying in front of the log, I've got to bring that up as a power. That was the last thing that I did on my expanding problem. Okay. The next thing that I'm going to do is I'm going to start with 2 of my logs and kind of condense them down to 1 log. And the sign in between these is addition. So I know I can bring it down to 1 log by multiplying the 2 inputs together. So x cubed y to the 4th. Now I'm going to bring down the log that I did not do anything with, which is z to the 4th. Now I've gone from 3 logs down to 2 logs. Now I'm ready to go down to 1 log. If I notice the sign in between is subtraction, so now I'm going to do division. There is a major mistake we make by trying to write the log twice because division. You're going to do a log here and a log here. No, no, no. Okay. Our goal is just to have 1 log. The division comes from the input of the 2 logs dividing each other. So the 1 log base 3, the first divided by the second. And there is my log completely condensed down to 1. Okay, so the next 2 days you have homework. I assign the delta math first so that when you're working these, you can check your answer or watch a video. And then on Friday, you have some book work. Do every other odd. And I will see you next Tuesday and Thursday. Have a great extended weekend.